Hello, welcome to the channel. This video is about the concept of standard deviation. This video is aimed at the HSC 2 Standard course. If you are not taking Standard 2, this might not be directly applicable. However, feel free to continue watching if you want to get an understanding about the concept. If you're taking Standard 2, you will not be expected to reproduce the math in this video. However, if you follow along, it should give you an intuitive understanding about the concept of standard deviation, what it is, which is necessary to understand the normal distribution, which is what the next video will be on. Consider the following distributions. All three have the same mean or average value, but the data is distributed very differently. In the first, it's very bunched up. In the second, it's a bit more spread out. And in the third, the data is very spread out. So how do we quantify this? You could give the minimum value, the maximum value, or the median. However, this can be very skewed by outlying data. The standard deviation allows us to get a measure for the average distance each data point is from the mean. The standard deviation isn't the mathematical average of the distances, but it is a similar concept, and thinking about it in this way can help you to understand how the standard deviation operates. So let's put some labels on things. The x with a line above it is called x bar, and simply means the average value. x1 is the first point, x2 the second point, and so on. The distance from the mean to x1 is x1 minus x bar. The distance to x2 is x2 minus x bar, and so on. It doesn't matter if the point itself is positive or negative. In this case, the mean is 0 for simplicity, however it could be any number, and keep this in mind as we move on to the next section. To construct the formula for standard deviation, we are going to use an analogy to the Cartesian distance formula. So consider the following diagram. In this example, we want to find the length of the line d, which we can do using the length of x and y. We do this using Pythagoras' theorem, c squared equals a squared plus b squared. Substituting in our values, this becomes d squared equals x squared plus y squared, and then d equals the square root of x squared plus y squared, or the square root of the sum of the squared distances. This works because we can form a right-angled triangle, but more generally because the coordinates of x and y are what we call independent of one another. This process generalizes to multiple dimensions. Consider the 3D coordinate system now. Putting labels on all the relevant points, we want to find the length OC. So we construct the triangle OAC. Again from Pythagoras, OC squared equals OA squared plus AC squared. And OC equals the square root of OA squared plus AC squared. The same as before. Now we keep this result and we can find the distance OD. Bringing back the previous result, the value for OC, and constructing a new triangle OCD, we get OD squared equals OC squared plus CD squared. Now substituting in our value for OC, we get OD squared is equal to the square of this square root plus the square of CD. Now the square and the square root simply cancel out, which gives us OD squared is equal to OA squared plus AC squared plus CD squared. Taking the square root of both sides, we get the result OD is equal to the square root of the sum of the squares of all of the individual lengths. OA is the x value, OB is the y value, and CD is the z value. This process generalizes for as many dimensions as we want to use, with the final length simply being the square root of the sum of all of the squared values. Now let's construct the formula. In the same way that the axis lengths are independent distances, the data points in a distribution can be considered independent points. We start with the distance of a single point away from the mean. Remember this from the beginning of the video. Now we square it. This ensures that the value is positive, as we are only dealing with distances away from the mean. Next, we sum the squared distances. That's what this squiggly symbol in front means. It's called sigma. It means to sum up the values. We use the subscript k here to indicate all values. So this represents the sum from k equals 1 to k equals n, where n is just the total number of values. So if we imagine the first point, k equals 1, and inside the brackets, x sub k becomes x sub 1, or the first x value. We write it this way so that we don't have to write out the whole sum. We're just describing the process. This allows us to write it the same way if we have 2 values, 3 values, or a million values. Next, we divide the whole sum by n, the number of values that we have. So if n is equal to 3, we divide by 3. Now what we have is the average of the squared values. So far, this is the same as taking the average, simply of the squared distances instead of the values themselves. Finally, we take the square root. And that's it. That's how we calculate standard deviation. I know this formula can look a bit unwieldy, but it's just describing a relatively easy process. In fact, the only difference between this formula and using Pythagoras to find the length of a line is that we divide by the total number of terms before applying the square root. Here's the formula written out once again. The symbol on the left is somewhat confusingly also called sigma. However, it's the lowercase sigma, whereas the sum symbol is the uppercase sigma. But it's just the symbol most commonly used to represent standard deviation. And here are what all of the symbols mean once again. As I said at the beginning of the video, if you're taking HSC Standard 2, you'll not be required to reproduce this math. However, I've gone through the trouble of writing it out like this because this is most likely what you will find online on sites like Wikipedia if you search for standard deviation while you're revising for your exams. And it can be one of those concepts that seems to come out of nowhere. But the key takeaway from this, and the thing that you need to remember, is that standard deviation is just a measure of how spread out the data is. Or put another way, if you knew the standard deviation of a dataset and were asked to guess how far away a random point was from the mean of the set, the standard deviation would be your best guess. The next video we'll be looking at the normal distribution, which is a distribution that is characterized only by its mean and standard deviation. Alright, that's it for this video. Thanks for studying with me, and I'll see you in the next one.